Myself, Fazira Razak Hamza, Assistant Professor, PG Department of Computer Science, and I'm here to present on the course Principles of Software Engineering. So, in the previous episode, I was narrating about software and software engineering introduction in Unit 1. Today it's the second episode of software and software engineering, and I'm starting with what is software engineering. See, we said that software engineering is a process for building software, or custom built softwares are being built using the software engineering process. So as such, when we say that when we are building a custom built software based on the software engineering process, we can say that it is an application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of the software. Okay, that we are applying engineering to software. How an engineering works, that let's see. So we can say that software engineering is a layered technology. We have so many layers, and it is a layered technology. Here we are engineering it with 4 layers. The first layer, or the foremost layer, the bedrock that supports software engineering, is a quality focus. Quality focus means we are ensuring as much as quality or higher quality for the software that we are being developing. Okay, so the bedrock that supports software engineering is a quality focus. Now, the foundation for software engineering is the process layer. Now let's see what does the software process layer does. Okay, we can say that the process is something that holds the technology layers together and enables timely development of computer software. We can say that process is something which can hold the technology layers together. We can say the technology layers means the upper 2 layers, that is methods or tools. All these technology are being held together by the process layer for development, for the timely development of the computer software. Okay, so we can say that the software process, we can say that it forms the basis for management control of software process, because we say that all these softwares, the development, the methods that we are implementing, the tools that we are using to develop the software, all these methods or all these tools are being managed by the software process, and it establishes the context in which technical methods are applied. Okay, where technical methods are applied, we can say that process methods are being controlled by the process which we apply. Then the process can keep track on work products that are being produced. Work products means the models we use, the forms we use, the data we use, the reports we use, and the documents which we prepare out of these softwares. That is known as work products which are produced. And the process can also establish or make use of the milestones that are being established. And also the process is ensure quality and change that is being properly managed for the development of the software. So we can say that software, it is the, as it is said here, that it is the foundation for software engineering. The process layer is the foundation, so it acts as an technology layer that holds all the methods, all the tools together and ensures quality, then milestones, work products, or methods that are being applied, everything. Okay, so here see, process defines a framework that must be established for effective delivery of software engineering technology. So it is a framework in which all these methods, tools, all these things are established, and we are ensuring the effective delivery of the software. Now I'll see the the layer above the process layer, that is known as the methods layer. The methods provide the technical how-tos for building software. How-tos means how we are developing the software, using which method, or using which model we are building a software. That is being engineered using the methods layer. While we say it in a broader way, we can say that methods just focus on a broad array of tasks that include tasks like we can say that the first and foremost thing we do while building a custom based software is that we first communicate with the customer, right? We first communicate with the customer or communicate with the stakeholder who is being demanding what to do with the software. So methods focus on a broad array of tasks that include communication, then requirement analysis. After communication, we have to analyze on the requirements, what all methods or what all tools, what all requirements or raw materials are needed for the development of the software. Then design modeling. Design modeling means what kind of models we can use to design the software. Then program construction, that means source code generation. We already in the introduction we say that we are building programs or instructions, a set of instructions based on the software, based on any language to develop a software. Then testing and support. We have to test the software, how the software is being whether it is well implemented according to the customer's demands. And also we have to give the support. Support means the maintenance part. Always the software, the first introduction itself we said that the software doesn't wear out, but it does deteriorate, right? So when deterioration happens, we have to always maintain the software according to the future uses. So a method, we can say that methods are taking care of all these things. Okay. Then it include the methods. We can say that software engineering methods mainly include modeling activities and other descriptive techniques. What all techniques we can implement on and other modeling activities means there are several models in software engineering which can be implemented to develop a software. So what all methods we can, what all models we can implement to develop a software. Then the topmost layer is the tools layer. See, here itself it is said that it provides automated or semi-automated support for the process and the methods. Okay, so it is the main thing which supports the lower levels known as the methods and the process layer. Let's see what it is being used for. See here, when we should integrate some of the other kind of tools to make these methods or process to come into engineering, right? Or come into build a software, we have to make use of certain kinds of tools. So when these tools are integrated, information created by one tool can be used by another tool. See, in the first introductory part itself, I said we can make use of, we can reuse the codes which we are developing for building a software. So in this case also, we can, when tools are integrated, we can make use of the tools for the purpose of reusing the tools with another system. So for supporting all these things, for supporting the tool to be reused, we are establishing, we are establishing a system known as computer-aided software engineering, where we can reuse all these tools which we are using for the development of the software. So these this is the layers which are included in software engineering. There is a figure depicting all these layers. First of all, I said it is quality focus is the bedrock. So it is in the last stage, and above that there is the process layer. Above that there is the methods layer, and there is the tools layer which provides support for the methods and the process layer. Now we are moving on to software process. What is the software process? Okay, we said software engineering is the process of building a custom-based software. So we can say that a process may be a collection of activities, actions, and tasks that are performed when a software is to be created. So we can say that there are activities, actions, tasks to be performed. Okay. So we can say that we can look onto what is these activities, what are the actions, what are the tasks that are being performed or that are being generated for the same. So activity, the first of all, activity means we want to know what is the objective. Okay, what is the objective of the customer or a stakeholder who have been demanding of the software. For example, when the activity, the first and foremost activity which includes is that communication with the stakeholders. So we can say that these communication is applied regardless of the application domain, size of the project, complexity of effort, or degree of rigor with which software engineer. So whatever process we are applying through the software engineering, it is not being affected by the activity is based on like what the, even if the software is large or complex or small, we have to do the first activity, that is communication with the stakeholders. Other than communication, we cannot know the demands, or we cannot know about the software, what is being developed or what is to be developed, or what all features the software is being implemented. So we have to first broad objective is to achieve communication with stakeholders or communication with customers. Now, what is action? See, after achieving an activity, that is after achieving a communication with the stakeholder, we get to know about the objective of the software, or we get to know what feature is being developed through this software. So we have to, the next step then we have to take is that we have to take an action, or we have to design according to the demands of the stakeholder, or according to the analysis which we have done with the stakeholder. We have to design an architecture that produces a major work product. So a model, design means we are implementing a model to develop the software. Then the third one is the task. So now task is that after we communicating with the consumer or stakeholder, and designing a model, we have to do certain tasks which will define the objective very clearly, and which will lead us to produce a work product. So a task is something which is like we can say that sometimes conducting a test on the uh, code, or on the code which we have generated, and whether the outcome of the code is suitable for the development of the software. So task focuses on the outcome of the program, or set of instructions which we have been designed or generated. Now the fourth one is the process framework. So inside these framework only, we complete, or we establish, or we make use of the software engineering process. So a process framework means we have certain framework activities that can be implemented on all software projects. Okay, so so we have to first, before doing a software engineering process, we have to well establish, or well study about the process framework. Now let's move on to what is a process framework. So a generic process framework for software engineering focuses on 5 activities. Let's see what are the 5 activities. What I have said, the first activity should be the communication. So before we are moving on to anything technical, or we are budgeting, or whatever we are doing, before all that we have to make or we have to importantly communicate, and get to know about the objectives of the project that a particular customer or stakeholder have been demanding. So first we have to do is that we have to communicate, and ask many questions as possible to the stakeholder or customer, and know about the project, and collect requirements based on these communication. So this is the first framework activity that we have to do. Now the second framework activity is planning. We are, as I said, we have to make a software project plan. Communication we have done with the customer or the stakeholder. And these software project plan is what defines what techniques that are to be conducted or are to be taken out in our project, or with whether the project is to be risk oriented, or what all resources are required, and work schedule, that means the timing which we have to complete this project and give back to the customer, or the work products which we are being produced in between of the developing of the software. The next one is modeling. That modeling means, I earlier itself said that we have to create certain, or we have to implement certain models to better understand the software or to work out the software project plan. The thing which the software engineer here does is that he sketches, or he or she sketches a model which is being mostly suited or mostly matching the requirements of the software. So another fourth process framework activity is construction. Construction means we are generating the code for the software according to the model or a plan which we have implemented. We are generating certain set of instructions or code based on the software, and we are testing the same, whether there is any bugs or errors in the code which we have been generated. Now the fifth activity is deployment. Deployment means we are delivering the project or we are delivering the software to the customer to evaluate, and we evaluate on the feedback of the customer. After deployment of the software, the customer will give some feedbacks, right? That sometimes they will say that their demand is not meted properly. Then that feedbacks are being evaluated and we are reworking on the same. Okay, so that is known as deployment, and these are the 5 activities related to process framework. Now, based on the activities, these activities, sometimes we should apply the framework activities iteratively from starting from the communication to the deployment, or otherwise we can linearly apply once and we'll get a desired software. Okay, so along with these framework activities, these framework activities to perform properly, we have to complement it with a number of umbrella activities. So we'll see what are these umbrella activities. The first umbrella activity that is being provided is software project tracking and control. So in project tracking and control, we actually take necessary action to maintain the schedule. Like in the sense, maintaining the schedule means in the sense we are keeping track of the time when the software is being delivered, and whether the software is being delivered on time to the customer. Then the second umbrella activity is risk management. That is, we already said that we'll be going through so many risks while developing a software. So first of all, before ensuring the quality of the product, we will assure on the risk which the project outcome will give us, and we will work on that risk and we will overcome all these things. Then software quality assurance. The first and foremost thing that while generating a software is that we have to ensure that the project is being delivered with highest quality. Then technical reviews. Technical reviews means we are conducting certain tests on the code generation framework activity. We are conducting certain tests to remove errors and bugs in the activity. So that is known as technical reviews. Now, another umbrella activity is measurement. That is, measurement means the process, the model, the product, then the resources which we are being collected or which we have defined for the same project is being measured or listed out. Then software configuration management. We already said that always the software is being deteriorated or affected or applied or always exposed to change. So managing all these effects of change is known as software configuration management. Then reusability management. we say all these software components, same as hardware, all the software components can be reused, right? But in the case of software components, we can reuse the code which we have been developed. Also, we said that in framework, we said that tools can be reused. Certain tools which we are being developed for designing a software can be reused in another software project. So tools are also being reused. So reusability management is also an umbrella activity. Then work product preparation and production. See, we said that during certain stages of the software development, we develop certain work products. So all these work products are prepared, and they are being made into a form, or either into a list or into a log or document or model, something like that. So all these are being recorded and keep track of. Then we are moving on to software engineering practice. What does software engineering practice means? These practice are done using the 4 steps that we have listed out here. The first step is understand the problem. Understand the problem means we are communication and analysis. These are all same repeated steps which I was saying, but it comes so all these steps come under different categories, and the same steps are being repeated. So the first one is understand the problem that we are communicating and analyzing. Then we are planning a solution. We already said that we'll keep after communicating, we will make use of a software project plan, that is modeling and software design. Then carry out the plan. Carry out the plan means we are generating certain set of instructions for developing all these softwares. That is carry out the plan or code generation. Then examine the result for accuracy. Examining means we are testing the codes and ensuring whether it is in the highest quality. So let's see how can we do the understanding the problems. Here we have listed out some questions to understand a problem. So by answering these few simple questions, we will get to know about the problem, and we will make use of the problem. See, all these questions are who has a stake in the solution to the problem. That is, who are the stakeholders. Okay. So according to them only we will develop the software. Then what are the unknowns, like what features are required to solve the problem. Then can the problem be compartmentalized? Compartmentalized means whether we can divide the problem into modules and work on separate modules. For understandability only we are dividing the problem or a project into modules. Now, can the problem be represented graphically? Can an analysis model be created, or can the problem be represented graphically? That is, this few questions are being asked in understanding the problem. All these things we are answering a few simple questions and doing a little work on that. Now, how can we plan a solution? Planning a solution means have you seen similar problems before? Okay, then has a similar problem been solved? Can sub-problems be defined? Then can you represent a solution in a manner that leads to effective implementation? So with all these things, we can do a little design on the problem which we have understood. Then carry out the plan means source code generation, right? So does the solution conform to the plan, and is source code traceable to the design model? So we have to generate a source code which is being compatible with the model which we have designed. Then is each component part of the solution provably correct? Okay. Then examine the result. Examine the result means we want to have a perfect solution for the same problem which we have discovered. So we have to uncover as many errors as possible. So is it possible to test each component part of the solution? So we have to find out a testing strategy which is being perfectly implemented on the code. Then, does the solution produce results that conform to the data, functions, and features that are required? So we have to just check whether the result is being conformed to the features which we have been demanded by the customer. Thank you so much for listening. We'll be continuing the class with the next episode. Thank you so much.